Okay, thank you everyone for joining us. Today I'm just going to run through the way that we start off our journey as designers. This is about us using Hubble, but this webinar is eligible for Green Star CPD points, so just follow the instructions on the screen there. And specifically this is targeted at architects, builders and so forth, also at homeowners, and that consulting stage right at the first point of sale, I guess, with land and so forth. So it's really about site evaluation, and I did touch on this briefly in a previous webinar, looking at how we use our IT at SUHO to predict performance from the planning stage. And hopefully you'll find this quite useful. But this particular webinar is actually focused for the majority on Hubble and also using Revit. So if there's any students out there, this is probably a really good example. And after the webinar, I'll actually give this file to Marco so that they can also develop it a little bit further. So I'm going to narrate as we go, and the example that I've got here today is essentially what we have as the 10-star site for the 10-star house. I will turn off my video or just move it if it does get in the way, so you might see the video of my face there moving at some points. So using the SAPA website, and you can see the URL up the top there. Basically what I'm going to do is take a snippet of that site using the snippy tool, which is in Windows, and then I'm actually going to save this as a JPEG so I can bring it in the background in Revit. So even at the planning stage, if you have a client that comes to you, or if you're a homeowner looking at the site itself, you can actually gain quite a lot of information, and in particular what I'm concerned with on this is where is north. Once I've saved that image, I can actually bring it into Revit and place it into the background. Now this Revit file is just a new template, it's nothing fancy, there's nothing in it, just because if it's for someone that hasn't used Revit before, hopefully they can revisit this video over and over again and learn how to do the basics in it so that they can evaluate their own site as well. So what I've done is place it in the site background. I know that this site is 31 meters long, so I'm actually going to create a boundary sketch for that particular site, and then I'll scale the image, and it's by 10 meters in this instance. There we go. So we're going to finish up the edge. So that's essentially showing the boundary of the site. Next, quite often when we're doing planning stages, I'll actually have a survey or something in the background, and I'll actually scale it to the correct size, and then I'll hide it so it's not in the way when I'm drawing. But for the purpose of this, I've scaled the SAPA map and I'll pop it in the background. I'm actually going to pin this property line in place just in case I accidentally try to move it when I'm moving something else. So the next thing I'm going to do is actually using the pick tool and use the boundary lines. I'm actually going to look at the council guidelines and put in the offsets, which is 6 meters from the western boundary, which is the street front, 2.5 from the back. What's interesting on these particular sites up at Woodford is the 1 metre either side of the building that a lot of the development has actually adopted. In our instance, and the example I'm going to show you, we actually used the southern boundary as a common wall because we owned the site next door, and we actually put the building further back so that we could get more north light in. So you can imagine if you have lots of these little developments close together and you've only got a metre either side of you and the boundary, you're not going to get much light in. Now, a very easy way to calculate the data that you need for Hubble, you can do in Revit, and I'm going to show you. So the reason I'm showing you how to set it up is so that you can actually do it in your own Revit file. Very easy, or you can add these little processes to your workflow as well. So what I'm doing is drawing around this boundary line, which is essentially showing how far the building needs to be set back in this instance. And what I am trying to do is also, in a second the screen will flick and it will show you the drawings that we used, but I'm actually just setting up which orientation is for true north. So true north is the site tilted towards north. It's natural orientation that you get off that SAPA map, and also you'll see it on Google Maps, but it's important so that you can actually look at the shading that is on the site and make sure that you are also looking at daylighting. In this particular example, we had really good daylighting because the floor plate was actually really short, the depth of it from where the northern window's in. So when we're drawing in Revit, I actually draw on Project North just to make sure that my lines are all straight. So I've done that in this instance. And just to show you, I've just drawn a section through. And again, I'm going through this quite fast because it is a lengthy video, but you'll be able to revisit this and replay it and watch it. So this section line, if I go to that view, it basically is cutting through the building and it's showing some walls that I have made. Because this is just the basic Revit template file as well, the grid heads and section heads and things like that aren't actually loaded into the project, but in terms of showing you the process and again integrating it into your own workflow, you'll have your own section heads and so forth. So I'm going to label this first floor here as the ground floor. It's essentially setting where the site is at. This next level that I've put in, I'm going to make it the ceiling height. And in this instance, the rooms on the south of the building, we've actually got a dropped ceiling, and then on the north we've got a higher ceiling. Okay. So in dimensioning that, I can see that I've just put that height in as just a generic height, but we can actually also ensure that all of the walls attach to these levels. So you can see the parameters that I've used on the left there. So I've got the ground floor, ceiling height. I can actually change that dimension. Just to a standard ceiling height. And the advantage of doing this, especially with Hubble, is because the way I'm going to set this project up, it can actually calculate the square meterage for me. Every time you move that level line, if your walls are attached to it, those figures will also change, and it makes a much quicker workflow. So what I've done is essentially creating what Revit does it's kind of like an Excel spreadsheet, I guess you can think of it. But basically I can pull into that under the family of walls different values that I might need to do a calculation. Okay, so this is what it looks like. So I haven't actually assigned any values to these walls. What I'm actually going to show you is a very quick and easy way of working out what walls face what direction and how many square meterage of walls there are. So you can see every time I end up updating these walls that those values in the area column will actually change. So I'm going to start grouping in this table here. So as I add a new property to one of those walls, in which case in this instance it will end up being the orientation, it'll actually reflect in this wall schedule. And you'll see how easy this is to get a square meterage out of. In this instance what I'm using is the mark parameter, which normally what we do if we're labelling doors or walls and things like that, it'll have a mark and say what number it is. In this instance what I'm using it for is actually to mark whether it's north, east, west or south, and that also means that in that wall schedule you can actually see it's automatically separating all of those square meterage that we can actually put into Hubble. Not necessarily as needed in terms of the basic walls, but when you come to doing the windows in a second you'll see why it's so valuable. So this wall here hasn't actually been connected properly, so I'll put that to ceiling. So that basic volume there is showing the height of those walls to the setback. What if we don't want a square box essentially on site? So what we start doing then is start looking at how we can cut up this space. We can do it a number of different ways. We can use what we call a curtain wall in Revit, which is essentially a window. We can change the size of it. In the table there you can see that it now says that there's a curtain wall family and it's giving a square meterage. What that actually also does is when that curtain wall is embedded into the basic wall, it actually takes that square meterage out of the basic wall. So again, I'm going to give it an orientation. Don't worry about that error that comes up because we'll sort that out soon. But this is a very, very simple way for someone who doesn't know how to use Revit very well to actually get all these values out that are useful in Hubble. And so you could actually do a design for a site plus a prelim evaluation, and this whole process took me about an hour, especially if you've already got a bit of a design for your site as well. Okay. So now I'm in Bluebeam currently, and I have just the plans and elevations, which might be all that you have in terms of pre-planning. These plans look pretty detailed because this is a development set, but in terms of just having something to measure off of and give you the example, I am just checking the offsets. So what I want to do is, although the council offsets might give you a certain value, you might think in terms of your sustainability knowledge that you want to increase those setbacks or things like that. So I'm just doing a measurement on there and changing it, 3.5 meters, and I'm just going to align the outer face of that wall. There we go. So every time I move a wall in terms of its shape or size, I can either assign the orientation of north, east, west, south, or I can split the wall or put windows in it. I'll update that table on the right. Okay. Now what I'm going to do is just work out where I want these walls to move to, just using a temporary grid line essentially, and I'm going to offset it the amount that I see on this plan. And this could be done from a hand sketch, so quite often I'll just do it from a hand sketch and then just make some assumptions in terms of the ceiling height in certain areas. Or I can create just a basic volume in Revit like I'm doing now, and then take the values off of that for Hubble. Okay, so let's offset that one again, and we're going to do the last one. So do that again. Okay, so you can see that I've placed some grid lines there which give me an idea of where to split these walls up. And then I've used the split tool. You'll notice that there's all these padlocks that need to be undone before you move the wall, so I'll do that first. Okay, and then in this instance we need to also work out what the other offset is, so you'll see that now. So what we're going to do is measure in Bluebeam roughly how tall this is. Okay, so I'm going to use the dimension tool, a little bit more exact in this instance. Okay, and then this wall also needs to come down. You can see that there's a little recess there, and in this point just here. So I'm going to put a measurement there so I know how to offset that one, and just make sure all the padlocks are taken off. Move it down, and this one also, padlocks are off, otherwise the whole wall will move. And work out the offset. Okay, measuring 2.5. Okay, so you can see the shape of this house starting at the moment. So I've still got my walls facing in certain directions, but what I'm doing is cutting it up. Now the reason I have chosen to do it this way is just to demonstrate to you, if you're looking at walls that are facing north, east, west, south, essentially that's not going to change if you split them up and then just move them further down. So this is how you start cutting up your volume for the sides essentially. In terms of Revit, you'll actually just need to unlock these tiny little things on the end, which means that it joins. It's essentially to join the walls together. So I can use the trim tool and make these join. Okay, going to drew my wall again, it down, got to make sure it's trimmed again. Okay, so I'm going to do that one. Good. So in Revit, you can turn the properties on and off on the wall of whether they join or not. In terms of the curtain panels, they can automatically embed. You can see my volume is being created at the top here. Okay. And then what we're doing now is having a look at the elevations and so forth. Okay, because we want to see how we can make this building look a little bit more like a real building instead of a box. So I've just got to make sure that your drawings are scaled. If you're doing a hand sketch, you could just assume that it's got a certain height. So 2.4, okay, good. So the drawing is scaled. And I know there's a corner of the building here. And there. And the boundary one is lower, and we've got a lower ceiling there as well. So I'm now setting up what could be a hand sketch into a Revit model very quickly. So this line that we have here is the level, which basically we had at the ceiling level. So now I've just changed that to what the height of the wall is on the south. I'm just going to draw the other levels in as well so they have them for a later stage. If you know the pitch of the roof, it's probably not absolutely vital at this point, but I always do it anyway, so I've got them there. And I'm actually using the offset, so I can pick the bottom ground plane and then offset it from that. And again, okay, good. So down the bottom you can see I've got a plan view. Top view is currently a section, and I'm actually flicking between Bluebeam to do measurements and then also Revit. And then we're going to take that table of data that we've got on the right and actually bring that into Hubble. Okay, good. Now we also need the little light well at the bottom there on the south. So part of the ventilation and lighting requirements for this particular building was actually to have this little courtyard. Okay, so once again I'm going to use a grid line to actually offset and find out where I need to place this particular courtyard. So I've got a measurement down the bottom there, 7.3 cm. And I'm going to offset and get the measurement of Bluebeam for the other one. Good. And then also how far away from the boundary it is. So now I've got a little box that I can draw around. So I am going to split this wall. Also got to make sure that those locks are turned off. So select that and then unlock it from all the other planes. You can see another little padlock there that's on. Okay, let's see if this moves without moving everything. Good. Okay, so we're starting to get that courtyard shape now. I'm going to turn that join on so that when I draw the other walls in that it joins together. And for the purpose of this I'm just drawing the exterior face. Now that's not joining because we need to click that little button. Good. And I'm just going to make that nice and even, just to make sure my wall areas are more accurate. Okay, good. So you're getting a few inside tips here in terms of how quickly we can do a performance model at SUHO using this software, and why we can possibly give a builder with the client a much easier estimation process, because there's a lot of data that's already in there. Expectations are also set in terms of the performance of the building, and then we can get a much better dialogue. Okay, so I've just measured the pitch of the roof. Now in Revit I wanted to make sure that I'm calculating the wall areas that are also going up to the roof. So I'm going to draw the roof on, and then we're going to attach these walls to the roof. Let me just make sure that we have them all allocated. So you can see the little cheat circle at the bottom that I used to orientate the view. It's actually got the north, east, west, south on there as well, so that I know what I'm labelling. This one's a west facing. Again, just disregard that little error in this instance. Later when you do documentation, obviously we use Mark to actually label everything, but in this instance we can use it for our benefit in Hubble by grouping. It's the beauty of Revit, that we can put everything in terms of its data together and group it and sort it. It's a very powerful tool. And this one's south facing, great. Something else that you can actually also do is click on the table on anything that doesn't have that allocation, and then it will actually highlight it in the model for you. Okay, so we're going to draw the roof now. So what we need to do is essentially show how much of an overhang we've got around the outside. Okay, and then we're going to put all this data into Hubble soon. Okay, so we've got our roof. So I'm going to look at my 3D view here to see it as it's building up. Okay, just put that at ceiling height so the roof starts in the right place. Okay, now we have our plan. So the parts that I'm starting to look at here are particularly around the west and the north face, because we have an overhang on this building. So we have a slight overhang on the eave on the front. We've got some wing walls that shade that western window as well. That we also used Revit to have a look at the daylighting to see what sort of angle they needed to be at. Which is why we've got such a striking front on the front of this 10-star house. And then I'm going to measure roughly where that eave is, so that we've got the overhang. And I know on the east of this building and the south there's no eaves. Okay, so I'm going to use that offset again. I'm going to offset the front. And 2400. And the east and south, as I said, don't have any. Okay. So what I'm going to do is just split this so I can join them. TR trim. Good. And now I'm going to select the other one, so I don't have an offset there. I need to select the eastern face. Okay, and we'll trim that together. Now I need to just allocate where the slope is coming from. I know it's 10 degrees, I've measured that before. And we rotate this, we can see that the roof is sloped. The other thing that I am going to do is just change the thickness of that roof so I get the surface area of that wall exact. So I'm going to go into the roof and change the structure to the thickness that I'll measure just now. Okay, it's quite a thick roof on this particular one. because we've got a raked ceiling inside of this house, there is quite a large surface area on the outside, which means that we can use the high level windows to our advantage. So we're making sure that that is pitching from 2400. I'm going to select all of these walls. If I hit tab while I'm hovering, I can actually select them all. And then that way, that surface area on the outside is exact. Okay. Now, so you can see if I select on the actual table itself, it highlights the walls that don't actually have the orientation allocated yet. So I'm going to select those walls and now mark them south. Just go OK for the purpose of this. And now those ones, mark them north. Okay, so it's all grouping together. Now comes the fun part, so we're going to do the glazing. Okay, so insert into the wall and it will adjust that table value and reduce the amount of surface area of the wall that we have in Revit. I need to start measuring those windows and putting them in. So again, if you had a hand sketch or just roughly knew the area, you can put that in also. Okay, got the height of the door, and I've also got the width done, so it's updating our square metre amount. I'm just going to disallow the join on that curtain wall just in case, because these ones are close together. Sometimes Revit will actually join the ends on before you want them to, which we don't want to have happen. Okay, the other thing I've just noticed, so I can cut this one in, but essentially if you go into the curtain wall, you automatically embed, it will automatically cut that wall, which is crucial for getting these square meterage amounts right for Hubble. Okay, so we're going to adjust these values now. So I've got the base offset out of Bluebeam, 950. It's essentially above the kitchen cabinet in this instance. This one also has some high level windows above it as well. It's the north, and we have a raked ceiling inside. So that one, again, I'm going to use the mark value just to group these together. Super easy way in the planning stage to actually do this in Revit and Hubble. And I'm just going to copy those just so I get these sides in the same place. And then I'm going to bring up the duplicates. Okay. Now, so we need the values for what these windows are going to be. If I hold down Control, I can select them both. And we're just going to change them to the dimensions in the project. So about 600, and from the floor, 29. $2,900 offset. Unconnected, so I can actually put a height. Okay, so they're in the right spot now. Doesn't matter if I don't have the doors actually in there, because I want the actual hole that is actually cutting inside of the wall. Okay, good. So we can go around and do all the other ones as well now. Okay, next door. Get the same measurements. I'm not going to measure the width of that top one because I want it the same width as the door. So the high level window, I'll just align the same. So I'm just going to put the door in first. Unconnected, so I can make the height what I need. Automatically embeds. Okay, and then I can start putting in my measurements. Great, same place, so got the measurement right. Same spot, good. Okay, label that one as well, so it's grouping. So I'm doing all the north glazing at the moment. I've got nothing behind the fence, but we do have one to the front of the building, very front room. Okay, the offset, and I want a width on this one. Okay, so I'm going to put these values into my model now. Okay. And then also in the bed, take the values from that, change it. So the height of the window is 600, and it's offset 1800. Because we've got a nice high ceiling in here, it's raked. Okay, give us its orientation again, north. Okay, so that's all the northern glazing, but as you'll see as we go around and do the other glazing and we'll group them, you'll see the table on the right change. Okay, so once again, putting in a curtain wall, which is essentially glazing, but it's just cutting into that wall. And again, just in terms of planning a site and a build, this is probably the quickest way to do it. This is 2400, so window. Okay. Height of the window as well. Let's just assume it's 2400. It's a little bit lower in the end because of the recessed blind out the front. Okay, and I'm going to say that that one is west. There we go, you can see the table on the right is updated. That's good. Okay, let's see what other bits we need. Okay, so back in blue beam, just also got the high level window that's above the entry door, also west facing. Just in here. In this instance I haven't actually put the front door in because in this particular project it's an airtight door, so I'm less concerned that that's going to affect the performance. If it is a regular door I would probably put it in, especially if it's glazed. Okay, and we're going to change these dimensions as well. Good. So you'll be fairly exact on this. Orientation is west. Great. Now I've got a little courtyard. So we need those measurements as well. I'm just going to estimate, because I don't have the section handy, I'm just going to estimate that they're at the same height for the bed, for the bathrooms, because we have a bench there and they're just above bench height. And the other one I know is a door to go into the bedroom. Okay. So now back in Revit. Going to give the width of the door, good, 720, and we're going to just assume the height of it is 2400. Okay. Okay. 2100 I think just is actually what we did, I think, just so the head height's matched roughly on these. Okay. So we're going to select this. Oops. Don't actually need the dimension. So we're going to change these bathroom ones as well. Again, we will allocate which orientation they're facing. 600. Base offset we're going to estimate so that the head height is 2100. So you can see if I rotate around here, you can see that they're embedding. And then also that is east facing. So now we have another curtain wall appearing in that table that is east facing. Do the same on this one. 600, 1500, which is 2100 head height. This one is facing south. Don't have much south facing on here on purpose. Okay, this one is western facing. Good. Okay, so there's nothing else along that south boundary, because in this particular instance there's another house there. It's a boundary wall. A window. I'm not going to do the inset for the rainwater tank in the plan. We'll leave that off in this instance. Let's focus on the other parts of the building. Okay, and what's the head height? Good. There we are. More height and width. Okay, now we're going to embed those eastern windows. I'll put them in the wall. So this one's in the kitchen. And then we're going to allocate its height and base offset. Okay, and I'm keeping it at 950 because I know there's the bench there and it was set so that the bottom was the same as the other side. And this one. Same situation. I'm going to make that 2100, just make it look like it's the same head height. Just for planning purposes, that's good enough. Okay, now these actually need to be labelled as east, and you'll see the table update. Okay, so we've got our square meterage. So now we're almost ready for Hubble. So if you don't want to manually calculate it in Bluebeam, or if you already have a Revit model, or doing just a live planning session, even with your client, this is a great way of doing it. I'm just also going to show you a little trick in terms of performance, just on a sidetrack, just very quickly. So I've had a lot of questions about how to look at the daylighting inside one of these models, because normally as designers, when we cut through in a plan and then you try to turn on the shadows, it won't show everything the way that you want it to. It'll show the shadows coming in at 1100 high off the ground floor plate. And in this instance we actually want to use a 3D view but turn off the perspective. And then if you put that in there and then you turn on your shadows, you should actually be able to get the proper penetration of that daylighting. The reason I show you that is because one thing is using Hubble, but it's also the integration into your design process and making things more sustainable. So this is a really easy way of checking how much daylighting you're getting into the building. In this instance we did this right at the beginning so we could see how much daylighting gets towards the back of the floor plate, and therefore we know that we don't need as much daylight, as much artificial lighting in this space. Okay, so that was June. We're going to do a copy of this so that we can compare December solstice. Good thing about Revit is you can also do a full day study if you need to, but by actually using a 3D view that is essentially perpendicular to the floor plate and the walls there, you can actually get it really accurate and doesn't cut everything out. Okay, I'm going to change that. Let's make it noon. Thereabouts. Ground plane is set at ground floor because if it was set higher then the shadows would be different. So in summer you can see that floor plate's very shaded. Winter there's a lot of light penetration. Okay. So you can do a solar study as well. Ground plane, ground floor. I'm going to go June, the winter solstice. Okay, and we're going to turn those shadows on. Okay, so you can preview the solar study and hit play and then see how far it gets through. And the reason I check this before going into Hubble is that way I can see if I need to make the building a little bit narrower, or if I can justify using artificial lights that are maybe LED, so energy efficient. Okay, I'm going to rename this one December so that you can see in 3D. So this is very handy for showing clients as well. A lot of homeowners want to know how much sun is going to get in, especially if we're working with thermal mass. So if we're using a slab on ground in particular on the Adelaide Plains, it's very important. So I'm going to change this to December. Ground plane, ground floor. Okay, very shaded. So it's working perfectly, this design. Hence why this particular design we're able to get to 10 stars is because we optimized everything from the beginning. Okay, so this is the Hubble interface you can see here. So I'm going to start a new project and you'll see how quick this is. There's a little bit of setup in Revit just to get those square meterage amounts in the different orientations that you want. Okay, now Hubble's got this really cool feature at the moment where you can do double story if you do need to. This is a single story. What you also need is how much area is inside of those walls. So I'm going to approximate using the room tag there. I'm going to tick single story. Now this location actually links into the climate data that we need to actually do the compliance model. So for a NatHERS rating we actually need to know what climate zone it's in, and this actually tells you. Which is why it's so important for architects and designers, because we're not necessarily trained in these climate zones and how to deal with it. So I can select, in this instance we actually had reverse brick veneers, we had the mass on the inside. I know the light colour of the roof. We had no floor insulation because it was slab on ground. Okay, floor area I was able to get from Revit if I just switch back. Good, so we'll put that in, 127. Okay, eave, we're just going to assume, when we measured one of those eaves, for the majority it was 500. I'm not going to use the 2400 measurement because that wasn't near many windows. And in this case, what's more important is getting this glazing to wall ratio more accurate. Okay, so I'm going to put these values in now. Just straight out of Revit. These windows are shaded. I know that they've got an external blind that's going to come down on the outside. We've actually got layered external shading with deciduous vines and the roller shutters on the outside of the windows as well. South, a very small amount of south facing on this particular one. Okay, south, we're going to put this in. West also. Now generally on most of the buildings that we'll do, you'll find that we are asking for shading on the north, east, west, although sometimes on buildings it's not required. It does give the occupants that level of adaptability to their comfort level, especially on west facing. Okay, in here I can actually put the actual U values now. So Hubble did a update recently. You used to be able to just use the slider and approximate the U values. But now we can actually get even more accurate. And you can see that I've already got a star rating at the top there. So I know in this orientation with this much surface area and surface area of window that it's actually performing really well. So now I can start optimizing the building and changing some of the variables. And you can see that the star rating at the top will update as we're changing these things. Okay, so obviously this building has been orientated to work really, really well north facing. But we can also simulate different scenarios. So say you're going into estimation and you're wanting to know how much brick could be afforded in the budget. Would it work better in fibre cement and so forth? We can actually change some values in here and do that prediction automatically. So this one, we know what type of windows we're actually trying to get and what the values are of them. Okay, 8.68 stars. So already just in basic orientation and using the 10-star house, which actually has a little bit more insulation than what we're able to put in here, you can see that we've got the perfect orientation, perfect volume and wall to window ratio for this particular climate zone. If we were to use fibre cement and change some of these values here, we can also see that the star rating will change. Colour of the roof. The colour of the roof relates to the colorbond colours also. Okay, so we can see the changes. So this star rating actually changes as you're doing it once you've done the first simulation, which is really handy. So you can see the cause and effect. Okay, let's have a look what else we have here. If you were to have fences and things close to the building, in this case we do also, you would also tick that shading button just to make sure that we have those values. Something that you could also test out while you've got Hubble open at the same time, especially in design phase. Say someone wants a really big, stacking door here out to a pool area. We can adjust those values. We've already got the area set up in Revit, so it automatically calculates. And then we can actually put that into this as well. So I can change that northern glazing to a different amount. I can rotate the building. So this rotate button shows if the home was orientated in a different orientation, if it was facing south instead of north and so forth. So I've just put that back to normal. Okay, and go shading again. Yep, brings it back up to 8.78. Okay, so in order to prove a bit of a point about why sustainability matters and why there's an issue in the industry at the moment is, and you can learn from Hubble by looking at this, and why there are houses still being built in Australia that are below 6 stars, is that the orientation and these basic fundamentals of planning are not done at the beginning. So 6 is actually a score out of 10. Under the National Construction Code, there is a way to get a building through that is lower than 6 stars. But why there is a problem with that is that it's very much demonstrating that things like orientation, wall to window ratio are not being thought about. And there is a common assumption throughout the industry that sustainability actually costs a hell of a lot more. So what I'm going to try to prove to you now is that it doesn't. And it's just purely about planning from the word go. So using this same model, I'm going to take this down to just a very basic spec. We're getting all these dark roofs around the areas, especially if you fly into Melbourne. Okay, so I don't have any windows shaded. Even with a single glazed aluminium, this orientation, which is perfect, and the ratio of wall to window, still get 7.55 stars. So apologies if I start getting fired up, but I'm really passionate about making sure that people are getting what they are going to be comfortable in. 7.8 stars still, and basic spec. So if the roof was vented, say if it was a tiled roof instead, still 7.22 stars. Okay. If this was in a different orientation, facing south, still over 6 stars. So why are these buildings going through under 6 stars? It's not great education out there at the moment in the industry. We are trying to push that a little bit further. This tool, if homeowners are sitting down with one of us and going through it, it's educating at the word go. The owners are actually able to take control of what they are actually getting. There's not a lot of transparency on what the star ratings actually mean, so I'm just directing you to this. This is actually just a website that explains what is actually assessed. So it doesn't actually assess how people are using the building inside, other than basic occupancy. And then in terms of the actual heating and cooling loads, you can see on this chart for Adelaide, which is where this particular building was rated in Hubble. A 6-star building has 96 megajoules per metre square. 10-star has 3. And so just to, once again, prove a point, apologies, I'm very fiery about this. So do the maths. And you could get 32 10-star houses for the same consumption as a 6-star house. 6-star is the minimum, so I really implore you to visit Hubble, speak to the guys there, and send through any questions that you have to us. So once again, if you're wanting CPD points, follow these instructions, and thank you very much for watching. Let's just see if there's any questions quickly. Okay, so I don't have any questions currently, so if you need any more tutorial on that, please replay the video. It was very quick. I will endeavour to release a video with the shortcut keys that I was pressing as I was doing things as well, especially for students or architects that are actually wanting to know how I was doing it. But it would be really great to see everyone trying to put the pressure on the industry to push it that little bit further forward, homeowners to be empowered to know what they're actually going to be living in, so that we can actually make that next step. So I'm really enthusiastic about what I'm seeing now with architects, builders and so forth, engineers. They're all signing up to this climate emergency. I feel like also homeowners need to sign up to this and then put pressure on the industry to actually find out what energy rating they're given. The potential is, however, if they could use Hubble themselves, they could actually find out what star rating they're getting, or they can plan for the beginning, or even before buying land, they can actually compare different types of land and see what they're going to get. So very, very powerful tool, and I'm really looking forward to seeing how this is actually going to change things for South Australia in particular, and hopefully we'll be on the front edge of it. So thank you very much for watching, and get in touch. Thanks.